moving into, we'll get to our first round of results. After we ran the simulation, we're going to visualize this and we say, okay, how do everything do? And so here we have our forecast error, so the weight plus bias over our 1 year, and we see all of our results plotted out below. And so we can kind of talk about them a little bit. So we have our ARIMA model, like the time series linear model we mentioned. And with the planar adjustment, you see it got a tiny bit better, right? Like just a smidge, but a tiny bit better. But what we really want to talk about is our other statistical model here, the theta model. So this is kind of the model I subbed in for exponential smoothing because theta is a very, very similarly constructed model, and it's very popular. It's really a great statistical method, and we see the massive jump we get with the planar adjustment from theta. So we can kind of say in both cases, okay, planar adjustment did not hurt the forecast, and it's something to be thought about as not necessarily a no-no, but you should be very careful. In the degree of adjustment that you have to make depends on the sophistication of your forecasting algorithm. And so these two, and I'm sure you would agree, but like these first two algorithms, theta and ARIMA here, are they're mathematically robust, but they're very simple, right? They're very simple concepts. While if we take a machine learning framework, it's often incredibly complex. And so hence we want to adjust the forecast less, most likely, right? If we give it the right information. And so
what would be like your greatest takeaway from what's the conclusion
here? Yeah, sure. So once we move to the left side of the graph, we can see machine learning simply dominates, right? And this is
significantly, by the way,
significant. Yes. And you'll see this effect oftentimes in most supply chains. You'll see like machine learning has a large increase, and sometimes you might not, right? It's something you have to test empirically on your own supply chain. But we see in our case, machine learning does far and away much better than even the statistical model with planar adjustment. And this is with no adjustment at all, right? And that's in both cases. So the first case, we just added the price and that was it. And then in the second case, we added the price plus some holiday specific features like we mentioned, and some other features to help the model capture those hierarchical relationships we mentioned. And so yes, the difference is stark. I mean, we see from the right side of the graph to the left, we went from a 70% weight plus bias to a 39%, which is huge. So
it's huge. If people would truly understand the impact of 1% increase in forecast accuracy, I mean, it is super significant. Like, it really, I can share with you some of the, Gartner's, benchmark, but eventually it is significant in revenue increase, in profit increase, in inventory reduction. It really is significant. So if you don't know, I won't get into it right now, but go ahead and look into it, and you would see. For example, let's look at both ends, like almost 40s and about 70. We're talking about 30%. That's a difference. It's huge. Now go and look into it, what it means in terms of financials. You would find that this is enormous what we see. It's a huge gap.
absolutely. Yeah. And kind of to your point as well, something that I thought is pertinent to bring up for, people in a supply chain leadership position is previously before I joined Daybreak, I was at a manufacturer and I was helping them with their supply chain forecast. And actually, I think we were forecasting like for hundreds or if not 1,000, I'm not 100% certain on the number of stores, but Home Depots here in the US, we were forecasting all their products. And what we saw is like in my supervisor who was in a leadership position, there's a big lack of trust in this new era of forecasting because the results look so good. And so that kind of highlights from our shoes, we need to make sure we set up our experiments in a robust way so that we can very clearly show and communicate, and supply chain leaders can be confident in saying, okay, this is actually how the model would have performed if we rolled back time and used it. Right. So that's something that
I think that Jack, you touched in one of the most critical points in all this webinar. You know why? Because at the end of the day, you can of course outperform, Excel spreadsheet, or even a basic statistical model like exponential smoothing or moving averages, but eventually you need to communicate it. And you need to share it with top management if you're going to transform something, or if you wish to implement the demand planning software. And I think this is, again, what you're showing is the art science, but in supply chain management, you need to know how to communicate it, and you need to build the right visuals, nice visual representation that really shows the power of machine learning and why your VP supply chain or your COO should strive to transform its supply chain with machine learning. I think this is the most challenging task in supply chain right now.
absolutely, yeah, building trust amongst leaders who have, understandably done things the same way for a long time and it's worked well, can be a challenge, but it is, yeah, like I said, it's important to really try and present these results and say, okay, with this back test type scenario, similar to how you might see in finance when they apply machine learning in finance, we have to simulate the supply chain with its conditions, right? With this forecast as the only change variable. Similar to how we do in finance, if we wanted to build something to optimize a portfolio and we say, okay, we're going to use our optimization algorithm under the market conditions, as long as we're not leaking information. So yeah, 100%, 100%. But we see, yeah, the results are huge. And so that's what sticks out, of course, immediately.